Hi, we're Team 6 and this is our final presentation. Our topic is generalizing VideoNet by expanding application domain. The paper for our project is Eyes Are Faster Than Hands, a soft wearable robot runs user intention from egocentric view. And this paper was presented 2019 Science Robotics, and the keyword of this paper is user intention and vision-based intention detection. The goal of this paper is present a learning-based intention detection methodology for spinal cord injury users. And this system comprises the wearable hand robot with actuation system and computing device which emulate intention output from VideoNet. The ExoGlobe Poly is used for the wearable hand robot, and the first-person view camera is mounted on the glasses. And the glove is manipulated by tendon-driven actuators in the actuation system. The methodology of this paper infer user intention through spatial and temporal information. And this figure is VideoNet architecture. This is composed of spatial and temporal subnetworks as depicted in this figure. The VideoNet takes the sequential images as an input to produce an intention output. We are going to apply this network structure to various applications. This paper can be divided into VideoNet and actuation part. VideoNet is vision-based intention detection network from egocentric view. The actuation part is composed of a wearable hand robot and actuation system. What we want to implement in this project is expand the application of VideoNet. So we replicate and transform only VideoNet, not the actuation part. But this paper is limited. The use of control only soft robotic glove for grasping and releasing objects. So we propose to expand the range of use for VideoNet, such as controlling mouse or remote controller or keyboard. So to expand the range of application of VideoNet, we will use two models with egocentric camera. Then we will provide the UI system that the user can register the object they want to control and how they want to control the object. To create the egocentric view, we use the glasses as shown in this paper, and disassemble the camera and attach it with the glasses. So we can make egocentric view cameras, and we use this camera for our project.
After progress presentation, we've trained the model to detect electronic devices for manipulation like laptop, mouse, keyboard. And since our project uses egocentric view, which the point of view follows the user's side, we made the object closest to the center of the view is selected if multiple devices are detected by the model. For the hand gesture detection model, we have finalized the model to clearly identify the hand motion with 3 gestures. This is our controller UI. In this main page, user can choose to register new device to the program or run the program for the registered device. In this figure, the device list box is empty since we haven't registered any device yet. We will show how this program works in the following slides. In the register function page, user can add device to the program and add their own function to the program. Device is selected by the object detection model. And as previously explained, object closest to the center of the view is selected. This is the register function page after user registers function for the device they have chosen. User can check which functions they have added in the box. And after user registers device to the program, they can check the device list in the main page. When user runs the program, they can control the device with their hand gesture and assigned function. The device to control is chosen by same method to register device page, and each hand gesture is connected to function that user have assigned. In the next slide, we will show our demo video how our program works.
Hello, I'll now start our group's presentation on the pilot test of our proposed interface. So here's our egocentric camera with intention detection using gesture detection. So first is the registration step. We register 3 different types of objects that you can see on the table: a mouse, keyboard, and a remote control for the air conditioner. So we use YOLO model to run the object detection, and then we type the name of the device that we're looking at, and then after we press OK, we register the different functions that we want to use with the object. So here we have 3 different functions, and in the box here you can see the list of all the functions that we registered. So I'll run forward. So we register 3 different types of objects in this manner. So once we are done with the object registration, we run the interface itself. So when you run the interface itself, we quickly, the model first runs the object detection model to recognize which object that we're looking at, and then we run the gesture recognition model. And on the right side, we can see 3 different commands. And so for this pilot test, we went through different hand gestures one at a time to show that all the 3 different gestures can be recognized by our model. So the fist corresponds to the first command, and the open palm corresponds to the second command, and finally, the number 2 hand gesture corresponds to the final and the third command. So in this manner, we demonstrated that our interface could successfully be used to recognize which object we wanted to control between 3 objects, and then distinguish which commands we wanted to use for that certain object using gesture recognition. So our interface and our system still has certain limitations that we should overcome in future research. So first of all, our entire system is bound to our desktop. The Glasses itself was wired to the computer using a USB cable, and our model itself was run in a desktop computer. So we think that suitable future research direction will be looking towards making our entire system portable and carryable, so we could use it in everyday life. So first thing first, the Glasses should be wireless, so the person could easily wear it and move around the house. And the registration UI should be ported to a mobile device, so a person can register any device conveniently while walking around the house instead of having to go back to the desktop. Yeah, and after that, one really difficult thing that we encountered during our project was maintaining this balance between the object detection model performance while keeping it lightweight enough to run in real time. But as you can see in our pilot test, the performance of the object detection model still went kind of haywire from time to time, making it difficult to have consistent performance. So improving the performance of the object detection model is also a priority that we should focus on as a future research. Another avenue of research that we considered was replacing and considering an alternative method of intention detection that does not obstruct the field of view. So currently we use gesture detection as an intention recognition model, but since the hand obstructs, to show gesture, our field of view is obstructed by our hands, which makes it difficult to run object recognition model in tandem with the gesture detection model. So we wanted to replace this gesture recognition model with another intention detection model or system that could possibly not obstruct the field of camera. So one possible candidate we were considering was using EEG signals to map our brain waves for gesture recognition by focusing on concentration level or so on. Thank you for listening to our presentation. This is all for today. Thank you.